Hello and welcome to a new session in our class of system designs. Today we are going to be talking about human-centered design, and this is going to take us two sessions. Today we are going to be doing the introduction. Next session we are going to be talking about the methods that we can utilize to implement the human-centered design. Then today learning objectives are going to be describe the human-centered design approach and its features, and as I said, next week we are going to be talking about the implementation and the methods that we can use to design different systems when we are using the user-centered design approach. As always, some abbreviations that we are going to be using is HCD, is the human-centered design, and it's a little bit interesting that we are going to be discussing what is the UI, and we have introduced that the user interface and the UX is the user experience. But when we look at these three terms, it's really common that people use them interchangeable, but it's important to understand that that's not necessarily true. Some of these, the human-centered design is the process to create the interfaces or to understand the process of creating a new interface. When the user interface is what we have explained before, are those elements to interact with a system that allows to put inputs and receive outputs, and the user experience is everything that is around. Sometimes people confound the terms and they use them interchangeable, and they are not interchangeable. But we are going to try to make some clarifications in that regards. Then important to recall the concept of usability. Remember, when we talk about usability, is that capability that a product has to be utilized by an user in an efficient and effective way while they are being satisfied with the use. And also, we have discussed before human factors, and it's when we apply the these concepts about human capabilities like the physical, sensory, emotional, intellectual characteristics and different limitations in designing tools. And when we talk about the user experience, is that perception, is that a way that the user feel as a result of interacting with a product or service, and are the emotions that are evoked by those interactions. Then usability is a characteristic of a product. Human factors are things that are going to modify the way that humans interact with devices, and the user experience is the effect and the feeling that people is going to have once they are interacting with the tools. Then, and as we have said, designing in public health is challenging. Why? Because the public health processes and practices sometimes are really difficult to define. They are not that straightforward. This is the function, this is what we want to do, or this is how we are reaching people. And when we try to develop clear definitions, then we need an effort, a collective effort, and bring different people and different perspectives into place. And the other thing is, a public health information system that meets the needs of one group, it can be challenging and produce more work or overload in other groups. Then that's something that we need to really understand. Oh yes, getting data is so easy, then we just translate that responsibility to a third party, and once the data is here we have the problem, but we don't we have we have our product, but we are not considering the problem that we have created in the other side, and that's why it's so challenging sometimes, and then important to have this kind of reflection. And the traditional way that we design systems is the universal design. And universal design, basically, you design a system that is intended to help everybody. And there are guidelines of universal design that is going to cover most of the people, and that's valid. And what universal designs in general says us that when we have usable systems, we are going to have multiple benefits, like including better productivity, the well-being of the user because we reduce the workload, avoidance of stress, increase accessibility, and reduce the risk of harm. But there are some difference. The universal designs put the user as part of the process, similar to the human-centered design. But the subject of study is not the user and the interactions. The subject of the study is the interface and how you can generalize the design of interfaces. An example of universal design are the guidelines to develop Apple products or Android products, or when we have these frameworks of usability, yes, they speed up the process, but sometimes we found that they are not enough for the needs that we have in a context. Then we need to modify the approach, and that's when user-centered design comes into play, that is going to have a more personalized, more target objective, in contrast with the concept of a universal design. At the end, we want to create accessible products, environments, and services regardless of their physical or cognitive abilities when we are talking about universal design. Then we don't take into account the particularities of the people, and we can have a bunch of recommendations then in that regards. Then when we want to talk about accessibility, then making something accessible is going to require a lot of investment. But what if you anticipate that the users, they are not going to need the kind of accessibility that you are implementing? That's why we need to extend the concept and go into the user-centered design process, and this is a philosophy, as I said before, that puts the user in the center of the design process. It was coined in the 80s by Donald Norman, and it defines the end users as the person that who is going to be using the product at the end, that the ultimate user. And then as I said, the object of study is not what is the interface, but what are the needs of the user and how we can produce solutions that are going to adapt to the user. The International Standard Organization extended the definition of the user-centered design to the human-centered design. And in that way, they are addressing impacts in other stakeholders, not just those that typically consider users. And then in that regards, we can consider what are going to be the administrators of systems, who are going to be the people that is contributing with data, or other systems that are feeding into our system, to be considered when we are designing the process. Then we are going to distribute these lightning questions, and why we want to do a human-centered design and user-centered design. Because we have significant challenges, definitely, when we want to design and implement a system that is going to be flexible, interoperable, and usable. And at the same time, we want to meet those needs of public health, and we already provide some kind of example. And when we ignore the user experience, we have found that there are a lot of projects that have failed. In the past, up to 60% of the projects fail. But they didn't fail because the technology was bad. They failed because we were not answering to the user needs. And these systems in the past has been rejected because we have not understand the needs, the workflow, or the architecture. And we still see this every single day. Now, when we are talking about artificial intelligence and all these models, there is a lot of new models, new things that people are doing with data. But nobody is thinking, hey, how are you going to put this into the workflow of the public health domain, of the population health? How is this is going to work? What is the type of architecture? How we ensemble this in the pipeline in order to be really useful? Why then we also are talking about, because human-centered approach has been used in the past, that has been useful in improving health outcomes. And as we have said, when we have usable systems, we are going to have benefits: productivity, well-being, less stress, more accessibility, and less harm. But what a human-centered design is or does? Uh, then when we think about that, human-centered design is sometimes called also design thinking. And it's a cycle that has like different steps, but you can move from one step to another one. And this is an image about the design thinking in extent. When you empathize with the user, you define the needs, you have some ideas, then you prototype and you test. And we are going to see that mostly of the human-centered design approach is going to follow this path. And empathize is, yes, you need to be in the shoes of the user, and you need to understand the user, and with the user you define their needs. And that's key word, needs, because the user, sometimes they know what they want, but not always what they want is what they really need. And then the job of the designer is to make the differentiation between the desires, the wants, and the needs. And in the user and the human-centered design, what we are going to do is to prioritize needs. And then if we have time, money, and other resources, then we go to the wants and the wishes. And that's part of that process of empathizing and then defining, ideating, prototyping, and testing. And we can go back and scratch things and redo them again. Then, as we said, the ISO extended the definition, and basically, when we talk about human-centered design, this is an approach for designing and developing to have a more usable interactive systems. And as I say, we focus on the user, and is going to be informed by the concept of human factors, ergonomics, and different usability knowledge and techniques. And we have introduced some of the human factors and some of the concepts of ergonomics before, and we are going to be building in that. At the end, the primary goal of the human-centered design is to create a document that we are going to call the user requirements. In the past, and in the traditional development ways, we have the system requirements. But as you see, requirements is not what the user requires, it's what the user needs. And this is going to be the key difference is not what the user wants, but at the end is how they are going to be conducting a task and what is going to be the best way of doing that. And at the end, the goal is to increase the usability of the product, and maximize the user satisfaction and increasing performance while we are keeping everybody safe. If we want to reduce the design thinking process, we can reduce that in three main steps. Understand the user, that has to be with empathize, uh, uh, I discover, ideate, and have that discussion, then prototype and evaluate. Or the other ways that have been called is discover, ideate, and prototype. But if you see, we have always the user, understanding the user and the beginning, and then we are going to have a prototype. We are not developing anything yet. We are just creating mock-ups, and that's part of the things that we are going to ask you to create with the final project, to create a prototype. And then we are going to evaluate those prototypes to be validated in some way. And the three stages that some other authors have said is discover. If you have a challenge, then you discover different ways to approach. Then you have some ideas, and you do this with the user. You share these ideas. It's not that you as designer have the ideas. No, the ideas needs to be built jointly with the user, and then we build prototypes that we are going to be evaluating, validating, and testing in some way even before we start developing. When we think about this approach, there is one of the most important effects, and is the human factors. And one of the human factors that is going to have the most important effects is the representation effect. And when we introduce human factors, we talk about so many things, but let's remember what is representation. Then representation is when something stands or represents something else. Then in this case, we have 6 different representations of the quantity 5. We can represent them with sticks, we can represent them with Arabic numbers, we can represent them with domino tiles, with words, in a die represented with dots, a little bit different like the domino, because actually that domino we need to do the adding, and this die is representing that quantity directly. Or we can have other kind of abstract representations. Then as you see, when we have a representation, a concept can be represented in so many ways. And that also happens when we are thinking about interfaces. And we can have exercises about, hey, how do you imagine things, for example? A table, the concept and the representation that you have in your mind, and how you represent a table can be different the way that I have that representation on my mind, and how I materialize that concept. Then the theory talks about the representation effect, and they say that different representations of the same structure of the same concept can have different challenges, different outcomes, different performance in conducting a task. And when we study human-computer interaction, it's perhaps the most important thing that we need to consider, because that's going to be impacting directly the performance. And how you present a problem is going to change the way that people understand the problem and how fast they are going to solve that. And also, if we have the right representation, then we can speed up the process of interacting. That's why when you think why Windows base, no Windows the operating system, but Windows concept systems are more efficient than command line, is because in command line, yes, first you need to rely on memory, but the other thing is the representation. The represented commands are represented in words that you need to learn, recall, and everything. But when you have icons, you are using your recall and not your recall, your recognition in order to interact. That is a shorter path in the human factors in order to access information. And let's do an exercise. And imagine this chessboard that has 3 by 3 9 tiles, and we have two opponents, one playing black, the other one playing white, but we are not playing chess here. The question is, can we switch the positions of the white knights with the black knights? If we can switch the positions, and if you don't know how chess is played, basically you can move the knights is in an L shape. You can move 3 and then 1. You can move 3 and then 1. This one can move 3 and then 1. Then if we can switch them, what are the minimum steps to do it? If not, why is not possible? Okay, then that's basically the problem. I try to think if you have an answer, and you can pause this video and try to solve it in your mind. But what if we represent this in a different way? And this is the same problem, because as you see, a knight that is in a blue square always is going to move to a white one, and there are two possibilities, and the ones that are in blue always are going to move, and once you are in the white, the only chance that you have is to move into a blue one. Okay, then if we reduce the complexity, then we see that we can move from a blue to a white that is empty, and then we can move from one blue to a white that is empty, because actually we have 4 empty white squares, and we have 5 blue squares where one is empty. And we don't need to put the empty blue one here, but this is going to help us to solve the problem, because we can anticipate that is going to be this sequence. I always need to move from the blue to a white, and from white to blue, blue to white, white to blue. And actually, if I see the problem in this sequence, it's really easy to see, oh yes, I may be able to solve the problem. And then I need to move this. This is the first one. This needs to be moved 1, 2, 3, 4 positions, and it's possible because I can just move them one after the other one, but I need to do that 4 times. Then the answer is yes, it's possible, and the minimum amount is 16 movements. That's the answer to the problem. And look how changing the representation and asking a different question. Can we just switch these two? With these two, we can just, yes, we just move one by one, and it's going to take 16 movements. And that's one of the examples of why representation is so important. And if we just transform the way that we present a problem, it's going to be much more easier to understand and solve challenges that we can face. Or look into a different problem. And this is another chessboard where we have removed the corners. And the question is, can this incomplete board be covered with dominoes that are going to be 1 by 2, 1 by 2, or 1 by 2? Then try to give it a thought about this problem to try to understand the representation effect. And you can pause the video and think about it and try to have an answer. But I'm going to show you the representation in a different way. when you remove the corners, then you are removing gray squares. And now, if you count the red squares, you are going to have 1, 2, 3, 4 in each line, and we have 1, 2, 3, 4, 5, 6, 7, 8. Then we can tell that we have 34 red squares. And since this is an A by A, we should have 64, then we anticipate that there are 32 gray, but we remove 2 grays, then we have 30. Now, in order to cover the board in 1 by 2, we need to have the same number of gray and red. Why? Because always there is a gray in the side of a red, or a red in the side of a gray. But since we don't have the same number of red and grays, then definitely we cannot cover the board with dominoes unless we cut them, because there is going to be always 2 red squares that are not going to have an available gray square in their side, and we don't have any 2 red side by side. Then if you think in that representation in a different way, you can see that, oh yes, now the answer is clear. I don't need to go and try all the combinations, all the experiments trying to put tiles there to try to cover that. Or the discussion between Copernicus and Ptolemy. These are 2 different representations of the solar system that are identical mathematically. One is the heliocentric, the other one is the geocentric approach, and one is more simple than the other one to explain the dynamic of the universe and the world, when actually this is a model representation of what is going on, because the sun is not static, the sun is moving and everything is going around that star that is moving as well. Then yes, we can have different understandings of the world, different representation, but this is something that we really need to understand when we are dealing with human-centered design. And we need to understand that representations are going to change the way that we interact. And then the represented world refers to those medical entities, objects, phenomena, events, procedures, whatever concepts we have there. And then they can be represented in different ways. And sometimes the way that we represent the universe of the public health using vocabularies doesn't match our mental concepts. And that external representing world is not matching with the internal representing world, and then we can have problems. And part of the design process is to try to create matching between mental concepts and the external representations. Then if my understanding of a table is different than your understanding of a table, maybe we are not going to be talking the same language, and then your image is going to be different than myself. And then we are going to have a miscommunication, or the concept of chair, or a concept of system, or a concept of peak, or a concept of key. Any concept, mental concept, cannot necessarily match exactly. Even though we share the vocabulary, our mental idea is going to be different. Then when we are interacting with the world, and here is where the representation is so important, Then we have a goal when we want to accomplish a task. Then we plan something, we have an intention, we do the planning, and we tell our brain and our muscles to execute that. When we do that in the physical system, and then we receive a result, we have our perception, our interpretation, and then we evaluate if we accomplish the goal. Then this is called the goal of execution, and this is the goal of evaluation. These are mental activities, and these are physical activities. As you see, there is a lot that is happening in our brains, but we need to support that with the physical systems. And the more that we can help to externalize in the physical system, the easier is the interpretation. And that's why the representation is so important, because with proper representations, these goals are going to be simpler. And going back to the example of interacting with a command line software or with a visual representation software. If I want to delete a file, for example, then the intention is to delete the file. Then if I'm going to do that in a command line, I need to, what is the command? What is the syntax? Then I need to type it. I see what happened. Sometimes I don't receive an error. Then since I didn't receive an error message, I need to confirm. Now I have another goal. And then how do I confirm? What is the command to confirm and list the different files? Then I need to list that, verify that, oh yes, I deleted the file. When you have a pictorial one, the goal is to delete the file, the intention is to delete the file. What is the action? You take the file and put that in the recycling bin. You just drag the icon into the recycling bin, it disappears from your folder, then you already perceive, yes, it has been deleted. And it's much more simple. And that's the idea of, hey, yes, representation is going to be everything. And is going to modify the way that we interact with the physical systems. And at the end, we want to have better representation. But then you may be asking, how can we achieve that? And that's that human-centered activities and the methods that we are going to be learning in the next sessions are going to help us. But again, then we need to specify the user, who is the user, and what is the context of the task that they are going to be using that. Then if, for example, you have an interaction that isn't going to be a noisy environment, maybe an audio interaction is not going to be the best one because you need to be filtering a lot of noise. Now, we specify the user requirements. Remember, and this is the process of identifying the user needs. When we identify the needs, we produce solutions that are going to answer for those requirements that are going to be, and we evaluate those proposed solutions against the requirements and validated by the user. As you see, they are linked to the requirements, they are always linked to the user, and if there is something that in the feedback, then maybe we need to iterate and produce a different representation. We need to produce another thing, and we evaluate that. And now, once everybody agrees, those are the solutions that meet the requirements, and those are the ones that we ask the developers to implement. Then, when we are doing human-centered design, definitely we need to consider the user, but as you see, we cannot be ignorant or just ignore the environment and the task that is being performed, because sometimes the environment is going to create some restrictions and the nature of the task is going to create another ones. Then imagine that somebody needs to be using some kind of equipment or be using some kind of devices that are going to be interfering in the interaction. Then maybe we need to look for different types of interaction. And let's say I'm wearing gloves. I cannot expect, and those gloves needs to be sterilized, I don't sterile, then I don't expect that person to be interacting with things that can be contaminated. Then how that interaction is going to happen, or how I'm going to make the input devices touchable without contaminating, and how is going to be all the maintenance of the process of being sterile, for example. Then in this regard, and if we want to think about usability, then we need to think about the attributes of usability, and we have mentioned them a little bit before, but something that is usable is easy to learn. The users are efficient using the system. They remember how to use the system quickly. The error rate is less with an optimized system, and they are, if there are some errors, they can recover from errors. They are not just stuck there. And at the end, the user is satisfied with the use of the use of the tool. Sometimes these attributes are going to create some conflict. And when we are designing, then we need to have some trade-offs with these attributes, because there is no perfect interface. But at the end, is what is going to be our performance measure that is going to be helping with this. Maybe some systems that are 100% satisfaction, they are going to be a little bit slower. Then that's something that we need to take into account. And an example is actually clicking is more expensive than typing. Talking about time. And there are people that can conduct tasks faster by typing, using the keyboard and using tab in a form, for example, instead of using the click to go from one field to another. And that's something that we need to take into account and consider when we are designing. In this regards, then Nielsen and the group, they created these guidelines about usability that we can evaluate when we are creating interfaces, or when we are evaluating interfaces. And these are basically rule of thumbs or heuristics when we are designing usable products. Then the first thing is we want to talk the user's language, and it's not just talking English, because which level of English we want to use. And for example, when you have forms that are coded and then you say, hey, S for sex 1 to 9, 1 for male, 2 for female, 9 for unknown, you need to learn the equivalence. And if you have a really long form, maybe you need to learn every single equivalence. It's better to have in a form just ask directly for male, female, unknown, or any other category of gender or sex that you want to use, and make that easier to recognize and to recall. The second heuristic is about tell the user what is the status of the system, and you need to provide appropriate feedback. And that's why sometimes we see this waiting circles or clocks or things like that that give us the impression that the system is doing something, or we say the system is thinking, when the systems are not smart, or they don't think. They're just taking time to process something or to use a result, but that's giving us some feedback in, oh yes, something is happening, then let's wait. And sometimes you have seen that, hey, you click and nothing happens, then and you click again, nothing happens, and at the end you have clicked 4 times and you receive multiple answers because the system was not providing a proper feedback of the status or the type of response that they were doing. Then that's something that we need to take into account. The other consideration is the user control and freedom. Allow the user to feel that they're in control, that they can have escape routes, that they can have undo and they can redo. because if you don't give the user control, they're going to be frustrated, and especially in the case that we are going to talk about errors, and you can undo something that's really problematic. The other thing is we need to have consistency and standards, and that then borrows from the universal design. Yes, universal design can inform us the human-centered design because there are things that are recommended, and sometimes we have standards and we want to have consistency in the way that we represent. Reinventing the wheel not always work that well, and the way that we, for example, present buttons or present menus or represent shortcuts, those are things that are really embedded into our brains. Then that's something important to take into account. And where you're going to be placing buttons, where you're going to be placing commands, the fonts, that type of things are really important to create that sense of consistency. We want to prevent errors, and then basically the design is to prevent errors, especially if you implement data checks, reducing memory load, having some appropriate defaults when you pre-populate forms, and disable controls that are irrelevant. For example, if you have a question that is yes, no, and you answer no, and the next questions don't apply, just hide them. Or don't show them until you ask the question, and if they only show them when the individual answer yes, and then you show the additional questions. Things like that are going to help you to prevent some errors, because you may create inconsistencies elsewhere, or things that are going to be really difficult to undo. Use recognition rather than recall. I have been talking about this, and this is about you don't want to force the memory of the individuals. You want to make objects, actions, and options visible, and minimize the load in the memory. The seventh recommendation, or the seventh heuristic, is to design for flexibility and efficiency in use, and then think that you are going to have novices, but with time you are going to have experts. Then allow the experts to speed up their process, and going back to the control and the speed process, then don't just have the interaction via clicks. Be able to implement proper tabbing and jumping from one field to another field in a form by tab when you are thinking about the design and the implementation. Also, flexibility is I prefer to have a dark screen instead of a white screen, because the contrast is better for me. Those are kind of things that are going to give us some flexibility, or if you have preferences in displaying data, things like that are going to enhance the way that the user interact with the system. And aesthetics and minimalism, and this is something that, look, this is just a heuristic. A lot of people think that a good user interface and a good user experience is just aesthetic. It's not. This is just one of the attributes, it's just one of the heuristics that we take into account. And you don't need to have an extra fancy design for something to be really usable. It's something that the user understands and they're pleased with that. And basically, it's more important in have minimal information than pretty things. And sometimes, for trying to make things pretty and put icons and a lot of rimbombant things, we made the system really cumbersome, and sometimes less is better. Simple icons sometimes are better than really elaborated images to represent things. We need to help users to recognize, diagnose, and recover from errors, and we prefer to have you must to do this, instead of saying we have an error and we don't point out what the error is. And we want to provide some help and documentation, and that's contextual and in the moment that we are doing that. Then these are 10 elements. The user language provide a status of the system, allow the user to feel that they are in control, be consistent across your interface and follow standards, prevent errors and allow the user to recover from there, use low memory loads, allow flexibility and the user to grow with the experience, be minimalist, help the people recover from errors, and document and provide help in the contextual way are the things that we want to identify. And we are going to learn how to do evaluation, how we grade this, and how we provide some tools to make this better. And the other thing, then once you use the heuristics, then you have an iterative process that basically, hey, we found some problems, we correct the problems, and then we do it again. And prototyping is just sketching and hands-on activities to entice or ask the users to provide us with feedback and to uncover things that we cannot uncover if we are not involving the users. And this can be or we are using surveys or structured interviews, because when they have something to work with, it's much better. And you don't need to have fancy things. You can just have a napkin and a pencil and do that. You can have a whiteboard and some markers to do this. That's the best way of doing that. And just put the thing there, visualize that, and start the process, and you will be having really interesting results. Then we have talked about what, why, what, how, but then when do we do this? And in the way that I have been talking, it has to be at the beginning of a process, but actually we can use human-centered design even in a product that has been already designed and we want to create a new version of things like that. But in order to help in the discussion, this is really useful when we have incomplete problem descriptions. An example is that we have problems in a system and there is no formal need assessment, and then we can use participatory design and we can use human-centered design in order to really understand what is going on. Sometimes we don't have the whole problem understood, and then we need to do that. Sometimes we don't have a clear pathway of designing, and yes, there could be so many ways of clarifying, but if you bring the user, then that's going to help us to improve that. Some of the problems that we can see is, what are going to be the impacts of the design? But if you have the user here, and you can do evaluations, and then you don't need to invest a lot of money in the development, and you can identify those problems really early, just with simple mockups, with simple interaction with the users. We have competing resources, and then we are going to be allocating the resources. Then yes, when we apply these methods, we can have a document design that is going to inform us what are the functionalities that are going to be most important and where we are going to be putting our money and our resources in order to solve these problems. When we have teams and collaboration that we need to integrate, how we prioritize, and then we bring the participatory design, we have the human-centered design, and we can try to reduce those complexities. I remember once I was working with a series of companies that they were sharing data. there were 8 different companies that they were sharing data, and they were having their own developing teams, and we were able to bring them together and have a discussion and have a common ground of the system design in order to improve the thing. And at the end they save a lot of money because they could collaborate in a common system that was going to be serving their needs, because they were sharing more than data. They were sharing processes, they were sharing things, and that's something that could be really interesting. uh, Sometimes we have unintended consequences of a design, and then when we have a scenario based design and human centered design that we already discussed this a little bit, is going to help us to identify things that we have not thought before. Who should be performing this? Then this is a team effort where we are going to have different people. We can have engineers, designers, stakeholders, marketing people. And of course, the user is going to be in the center of all this. But this is not something that is just from the domain of the designer. This is something that everybody in the team that is involved in a product development should be knowing about, and understand the heuristics, and understand the process, understand the difference between needs and the difference between wants and wishes. Just informing the people and creating teams that are oriented to the same goal, that is just the performance of the tool, is going to be really useful. Then the final thoughts that we can have, in order to consider that a process is a human-centered design, then the design is based on understanding the users, what they do, and their environment. And we illustrated that at the beginning. Because the task can be the same, but the environment is different, and that's going to modify the way that we are going to implement the solutions. Users needs to be involved all the way from the design to development, and they are going to be the ones that are going to be providing us with insight. And you can see that here in that process is going to be informed by user-centered evaluation. And we can use another methods like the participatory design, the scenario-based design, to help in the process of interactivity. And in different stages, we can bring some of those methods in order to borrow and help us in that design. The design then addresses a whole user experience, and that's why we borrow from these methods that we have exposed and presented previously in our class. And we are going to have multidisciplinary skills and perspectives in the design team in order to be successful. And of course, when we are talking about the user, we have in mind that human factors, ergonomics, and the representation effect are going to be the most important things in that iterative process of creating those prototypes. Here then we have some references. Looking forward for your questions by email or in the chat, the participation in the board, and we are going to be having a midterm that is more a reading comprehension as the quiz. Please allocate time. That's why we have a shorter talk today, then we compensate for the other time that you are going to be reviewing material and taking that midterm. And we'll be moving soon to progress, and I'll be providing feedback in your projects that they are in general fantastic. Thank you very much and have a good one.